Okay, so next thing that we are going to cover in this timer section is the input capture. So we can use input capture in many applications like recording the arrival time of an event, pulse width measurement, or maybe a period measurement. And we can either use a timer 1 or timer 3 Nutmega 128 in order to detect and measure the events happening outside of the chip. So when an event is detected, the TCNT value is loaded into ICR1 register and the ICF1 is set, for example, or ICFN value is set. So you can see the architecture inside of the AVR and the pins that ICP1 is in PD4 and ICP3 is in PE7. So from the data bus, the ICP pin over here, okay, and we can have the use either this as a analog comparator or we can use it as an input capture. So in the ACSR register, there is a multiplexer, as you can see, and the multiplexer select line ACIC, which is analog comparator and input capture select line. You can select if you want to use analog comparator or ICP pin. Then there's a noise canceller as well. So we can use a noise canceller in order to activate noise cancelling. So you can actually set these in order to prevent the noise detection of the noises. So it causes 4 clocks of delay from the event occurrence to the load of the ICR1 register. Then the edge detector, you can capture on the falling edge, on the rising edge. So we can use the ICES1 or ICSN bit in order to capture the falling edge or the rising edge of the event. And then the ICFN is set for interrupt, and then it will be loaded the data from the ICRN register and so on. And in order to deal with these, you can see the TCCR1B and TCCR3B registers, the ICNC1 and ICNC3, which is the noise canceller, disabled and enable bits. And we have got the input capture select, rising edge or the falling edge, as I already mentioned. And from the ACSR register, we have to select the set it to 0 for the input capture mode. Okay, or you can just leave it as a default because default is always 0. And then we can measure the duty cycle and the period. Those are the two main major applications that we can do with the input capture modes. And so the period is from the one edge to the other. So you can see 2 pulses over there, or you can just measure the pulse width. So some important points over here. We need enough processor capacity so that we can assign it to incoming capturing events. ICRN register may be overwritten if the capture timer value is not read. So you have to copy that value to somewhere else before the next event. So some of the event actions that we can have, read the ICRN first, then change the trigger edge if a duty cycle will be measured because rising edge or the falling edge will be done. And then input capture flag should be cleared if not using the interrupt because interrupt is clearing it automatically. And if noise canceller is used, there will be a 4 microcontroller clock cycle of delays, as I already mentioned that. Okay, so what are the steps in order to configure the input capture mode to do some operation? So for example, in order to measure a period, we can do these steps. We have to initialize, maybe I can write this, initialize TCCR 1A and TCCR 1B. So that's for timer 1, let's say. And then initialize ACSR to select the desired event source, and then monitor the ICF1 flag in TIFR in order to check if the edges has arrived. So once the edge has arrived, the arrival of the edge, so the TCNT or let's say save the ICR1, so monitor the ICF1 flag to see if the second edge has arrived. And then TCNT1 is loaded into ICR1 register, and then we save the ICR1 for the second edge. And by subtracting the second edge value from the first edge, we set the time for it. Okay, so let's see the example. Assuming that the clock pulses are fed into the pin port D, write a program to measure the period of pulses, place the binary result on port A and port B. So first thing to do, let's initialize the ports. So LDI R16 0 hex FF, out DDRA R16. So port A as out, and then out DDRB R16, port B as out, and then this is tricky one, out DDR port D R16. Now this is because the port D is going to be pull up activated. Okay, so we can set it this way. Then the ports are done. Let's set up the timers. So LDI R20 0 hex 0 for TCCRA, we don't need to set anything. So I'm just making the default TCCRA is going to be R20. And that's going to be timer normal mode. And then TCCR, this was 1A. LDI TCCR, this is 1A. Let's do 1B. So R20. Now in 1B, noise canceller disabled, ICS on the rising edge, we can set it. No prescaler, so 001, and the mode is a normal mode, so it's going to be 000. So that's going to be 4 and 1. So that means 0 hex 4 1, which is going to be rising edge. No prescaler, no noise canceller. And then we have to load this into TCCR1B, that's R20. So timer configuration is done for input capture. Then we have to monitor the flag of the input capture. And to do that, we do in R21. Let's monitor 21. Put those into 21. TIFR. So Then we can say SPRS skip next. So R21, we have to ICF1. So skip next instruction if ICF1 is set. And then after SPRS, if we are going to skip, we have to skip our jump. Otherwise, we have to re-monitor it until it is set. Then what we are doing, so if it is set, we have to get the value of ICR1L and ICR1H. So in our 23, then we have ICR1L, which is the low byte. So R23 will be equal to ICR1L, and the temp is going to be ICR1H, because we cannot have that both at the same time. So ICR1H will be stored in the temp. This is going to be the first edge value. Then we input, we load R24 with ICR1H. So R24 will have the value of ICR1H. And now, as we have got the values, we can say we copy these ICR values into the GPRs, so we don't need to worry about it anymore, and we can clear the flag. So out TIFR R21, we clear the flag by setting it, so ICF1 equals 0 in this case, and then we look for the second one. So what we are actually doing is we are actually repeating this instruction over here. So I'll redo that. And this is going to be L2 because we have to jump to L2 this time. And this will be L2. So now we monitor for another flag. And if we receive that, we can say, okay, out, clear the flag, TIFR R21. So clear ICF1. And then we input the second values. So in R22, and that's going to be ICR1L. So R22 will have ICR1L, and temp will have ICR1H. And this is going to be the second edge value. So then what we need to do is we have to subtract the first edge from the second edge. So I can do subtract R22. The first edge was stored in R23. So I can have the period as second edge minus first edge. Okay, so second edge minus the first edge will give us the period. And we have to send to port A the value of R22. So port A will be R22. And then we load the high byte. So in R22, ICR1H, R22 equals the temp, which is the high byte. And then we have to do a subtract with carry because we have got we can have a carry from the previous or the borrow in this case. So SBC R22 R24. And that's going to be R22 equals R22 minus R24 minus C. Okay, so this is subtract with carry. And then we'll have out port B, we'll have the second value, R22, and that will be port B equals R22. And we just repeat this. We just wait there forever. And that's going to be L3. Okay, so initializing ports, initialize the timer, configure it for input capture, and then check for the flag. If it is set, then read the ICR1L and ICR1H for the first edge, which is going to be this one, and clear the flag and look for another set for the second edge. Then when the second edge is detected, clear the flag, load the low byte, and then second edge minus first edge so that we can see the periods over here and the high byte of it so that we can get the values and send it to port A and port B as required. And you can also see the C version of this here. So the pins and the flags that we are monitoring are also here. And DDR-A as hex F, DDR-B as an output, port D as an active pull-up input. So TCCR1A0, 41 for the rising edge, no prescaler, no noise. And then wait for the flag. Then put your value into T, clear the flag, then wait for the next flag, and then do the subtraction and send the values into port A and port B. That's it. So that's all we need to know about the input capture. And if you have any questions or anything to ask, you can do that in the live session.